All right, hello. We're going to go ahead and get started on Chapter 8. We're going to talk about some of the PowerPoints here and working with text processing. Another word for that is parsing and tokenizing. It's essentially how your compiler works or an interpreter works when it interprets code. Is you got to parse the code, the text file, and then you've got to tokenize it, separate it out, and then make decisions based on your tokens. It's also something, heavy readily in user input and output, because regardless of where you're at, even if you're in a graphical user interface, if you're getting something typed by the user, such as a numerical value, it's actually coming to you not as a number. It's coming to you as a string or a character array of numbers. And then if you get a number from the user, like they type in the 2 and the 5, and you're trying to process the number 25, you're actually getting the ASCII code numerical value of 50 here, which is the 2, and then the 5 is the numerical value of 53. So you got to take those two bytes that represent those two different ASCII values, and you got to actually convert them to the integer 25. So whenever you're working with input and output, when it comes from the user, it always comes as a string or a character array. Whenever it's output to the user, it always has to be converted back to a string or a character array before it can go to the standard output and print on the screen or your console. And then, of course, when you're working with parsing and tokenizing, the characters that you're always working with is the characters that are on the keyboard. There's 128 of them, 0 to 127. And then, of course, you're going to be parsing and tokenizing these characters if you're building, an interpreter or a compiler. So parsing and tokenizing, working with text is a big deal because everything that you get as input and output from the keyboard of the user is text. And then, of course, it's how compilers are built. So let's go ahead and talk about the PowerPoint real quick, and I'm going to go into a few particulars, and then we're going to go ahead and complete number 10 of your assignment. I believe it's called the word counter. And we'll use the split method, and I may need to rummage around in your book as we build up the code. So let's go ahead and make sure that we kind of talk a little bit about everything with the PowerPoint. And I'm going to go ahead and bring that up over here. So we're going to talk about what's called wrapper classes, and this is important because here is the issue about primitive data types. Often you would, input data as a primitive data, but you need to apply functions to them. The string class we have, when you build the string class, you can directly apply a function or several functions to them. So this wrapper class is just essentially it extends the capabilities of your primitive data types, and so it's an object that's off to the side that you can use, and you can pass it that data. So even integers, most of these for the most part you can consider as objects in Java. So actually, let's go back to the PowerPoint here. So that's kind of the idea of wrapper classes. Is you use the class name itself to operate on a string, or you use the character class name to operate on a char, or the integer class name to operate on an int or integer wrapper, not class name. So you get a wrapper class for all your primitive data types, and so essentially what you can do is it's all built so that you can do operations, common operations on those primitive data types, because no matter what, everything in the computer is a number. Even your images are a series of numbers. So it always comes down to straight literally ones and zeros. So when we start taking things like the ASCII code and we have letters, well, the letters need to be assigned a numerical value, such as the capital F is assigned the numerical value 70. And you can go back and forth between those numerical values using typecasting. So there's a lot of functions that are given to us to use to manipulate and work upon our primitive data types in Java. In fact, every language has that capability. Or most of these functions that you're looking at are fairly standard. They're standard. They're standardly available for pretty much all languages. There's some of them are, as far as different languages are concerned, some of them are implemented in different ways. So let's go ahead and go back to our slides here. Let's see. So here is some of the wrapper methods for the character class. You can create a char, you can detect if it's letter. You can actually just build this yourself. This wrapper class, you can build this yourself. So you just take the char and you convert it to an integer, and you look at it, and if it's between a specific numerical value in the ASCII, ASCII code, it's a char. So these functions are very simple to build. You just take the character, the char, convert it to its integer value. And so let's say that we enter, we have a char, and in fact, let's say that we're going to go ahead and let's just throw it in here. And what we'll do is we'll do a char chr equals, let's say, the numerical value 2. And what we're going to do is we're going to look at that char and see if it's a numerical value or if it's a number, because it could also be assigned as an A. So most of the things that you'll be looking at for char data types is, is it an alpha? I just had a crazy border collie come in the door. So is it an alpha, or is it a digit? What kind of char is it? And so what we can do is we can create an integer called ICHR, and we can assign it to the integer value of CHR, the char, and we can look and see if ICHR, the integer value of the, we can say, hey, if the integer value of the char that we've assigned, the letter A, we take first and convert that character to its integer equivalent. And then we say, hey, is that integer char? Well, how do we look at it? Well, duh, it's the ASCII code. So we go back here to the ASCII code, and we can look at that, and we can say, hey, if the integer equivalent of that char is 49, is between 49, or 48, excuse me, 48 is the character 0, and it's between 57, it's a char. So we can do something like this. If CHR is greater than or equal to 48, and ICHR is less than or equal to, what was it, 50 or something like that? I think it was 57. Then we know, hey, we can print it's a char, that sort of thing. So that this is very simply, we can build these functions ourselves with the char data type. So a lot of what we're looking at is things that are built just to make it easier, instead of us having to take the character, convert it to its integer equivalent, and then looking at its range of values within the ASCII table chart. we can just run a function on it is if it is, you know, digit or is it alpha, and we don't have to write all this silly code that we wouldn't need to. We could build our own function for it as well. So, you know, the example being now that we change this to let's look at the PowerPoint again. Let's see. So it says is letter is digit, so it's going to be is digit. We're going to use the character wrapper class, so I believe we would use something like character dot is digit. Instead of doing all that stuff, we could just do simply, instead of converting it and looking at its range in the ASCII chart, we can say, hey, is it a character dot is digit? And you see it kind of pops up with everything, and you see it takes a char or an integer. You can send it the integer equivalent of that character. We say, is it a digit? And oh, look at the autofill. Isn't that so sweet? Oh, you are so nice to me. You already put in the char that I just created. So if this was the number 2, we would know that the user actually entered a digit, and things would be good. So that's kind of the idea of the wrapper class. It is very simple functions that are used a lot. It kind of is silly to make them ourselves. They're easy to make. And so every primitive data type has that. Another thing that is very common is taking that 25 and converting it to an actual, you know, if this is a series of numbers, we wouldn't use char, we'd use a string, or, you know, a char array. We could use a char array of 2 and 5 together, and then convert that to the actual numerical value 25. So that's kind of some of the ideas behind some of that, but looks like I've got a crazy naughty border collie that I've got to deal with, and I'll be right back. All right, we're back. Got that little bit of an issue dealt with. We're gonna go ahead and continue on with our PowerPoints, and then of course we're gonna get into this here pretty soon. And we've been talking about wrapper classes. The char class, we have the different functions that you can apply to a character to check whether it's lowercase, uppercase, letter, you know, and it's a Boolean, and you use it in this manner where you, of course I didn't put the right print statement in there, but essentially you use that character keyword and then the member access operator, and you pass the character you want to check, and then what's returned and what the if statement's looking at is the Boolean. So all those return a Boolean, and they're all intended to work within an if statement. All right, let's continue on. We've got some substrings with the string class here. One of the main things that you're going to be working with is strings and substrings. In fact, we're going to get into that today with our word counter. So you may have functions where you want to see if any one string starts with another. You may see if it ends, or if there's any specific matches in the string. Essentially you're looking for keywords when you parse and tokenize. And of course we're going to play with substrings and splitting strings here in a little while. So there's all kinds of different functions you can work with on strings. And let's see what we got here. So another thing that you would want to know about is, hey, where in the string does this keyword begin with, and how large is it, so that you can parse out strings within a string. And extracting substrings, here's an example. We could decide that we want to look at the substring, 14 characters of a substring, and it would grab the first 14 characters of substring. And you know, there's all kinds of ways of manipulating strings. And here's another big one. Get chars, to-char array. A string is just an object that contains a char array. So it's an array of char characters, the primitive data type. So a string is actually an object. It's not a wrapper. It's an object that contains the array of primitive chars, and you can actually work with just an array of chars if you wish. And then, of course, you can, the concat function is, you know, we've got the plus that does the same thing, essentially. And the plus operator is just, it's an overloaded operator that uses the concat. And then, of course, replace and trim. The trim is used a lot for trimming like spaces at the end of a string or at the beginning of a string. And you know what? Let's keep going on here. We got the string builder class. You guys can play with that. I want to kind of get into having some fun here. I don't want to get too, here we go, string tokenizer. So the string toker class is one thing that you can use to break down a string into its component parts that are called, you know, we call them tokens. It's also kind of, it's the split function used in other programming languages, but essentially you want to read in, you say you get a sentence and the whole sentence is in one string. And you want to break that sentence up into words. So you can separate that based on a specific delimiter, such as the semicolon. If you need to read in a comma separated values or CSV file, where it's just a string of numbers. And again, you would have to create these numbers, or you would have to convert these numbers when you're reading them into an actual number from its ASCII example. So the string tokenizer to break up strings, I believe they could, you know, it's a kind of, we could use the split function of the string class itself to kind of do the same thing, but the string tokenizer is, you know, a larger, you know, it has more capabilities. So, okay, so here is an example of tokenizing a string. You would set up the tokenizer, set it up to have, you know, I believe it defaults with, you would pass it what, you would set what you want it to separate values on. By default, when you create it, it's going to separate values based on spaces. So that's why this code doesn't show that being, you know, setting the particular token separator or delimiter. And then you can run a while loop while you're looking at tokens. You can go and parse through by using the next token function. And what this does is it's different from the split method, which I believe we probably might be using. We'll probably do it both ways. We'll do the string tokenizer class, and we'll use the string split method for our word count problem. But what this does is it makes it so that, because the split method, you have to store the words that you break out of a sentence into a string array. Here, you can just use a while loop to parse through them token by token to you know, process them so that you don't have to store them in an array. Okay, so you can have multiple delimiters for the string tokenizer when you set up the delimiters. Some common delimiters that you will always see is the \n. That is a new line. That is a new line for Unix text files. The \r with a \n is a new line that is for DOS type systems and Windows systems. So you will see files, they've pretty much made that a little on the seamless side now, where you can go from a Unix generated file with new line delimiters with a \n to a Windows based which is a \r \n. but it used to be a big deal having to string. If you created a file, you'd have to strip out. If you created a file in Windows, you'd have to strip out all the \R's so that that text file could be in a Unix system. So let's see here. When it instantiates the new tokenizer, this time instead of going with the default, what you're doing is you're passing the delimiter dot and @ symbol, and that's what it'll tokenize based on. So you can pass it multiple delimiters, characters to delimitate based on, with just a string when you instantiate the string tokenizer. If you don't pass it, if you don't pass this, it'll tokenize based on the default spaces. Now this gets into our split method that I was talking to you about. Notice how that you have to take the tokens and you tell it to split based on it. So what we're going to do is we're going to do number 10 based on both of these methods, and then that's going to pretty much be my goal for today. Now, as far as some of the other stuff in this, these PowerPoints in this chapter, you know, look into them. They're essentially tools that are used constantly in computer science, that are available to you in these wrapper classes. One of the main one that I wanted to kind of talk about is parse methods. You should be putting these in try catches, by the way, because they throw exceptions. Because when you parse an input from the user, say your input is the value is 25.99. When it comes from the user, it's always a string. So they put a literal string. This is an example of using a literal string to parse out what they expect to be an int. So you use the integer wrapper class and you tell it to parse an int, and it's going to grab that 25.99 and store it into an integer variable as the return value. So this is a very common tool that you have to use when you're getting input from the user. You've already used it. I believed it was on one of your exams. So you want to surround that with a try catch. And you know what? We may just do a little brief by the side play with this. And actually, you know what? Let's add that to our list for fun today. We're going to do the number 10 word counter, but hopefully I don't forget to come back and do the integer. We're going to create a file of integers and add them all up with. We'll just ask the user form and add them up. All right, so let's actually stop here, and let's go into writing some code. Of course, I'm going to have to come back and look at the book and stuff. I might pause a few times just to look up particular syntax, and of course, I'm going to create have a break time, and then obviously, we're going to have some naughty border collies probably happen. So let's go ahead and begin. Now, what we're going to do is we're going to take the code that we worked with last week in chapter 7 to load in a file, and we're gonna duplicate that. So I'm just gonna look at that code that we built for chapter 7 to load in a file, and we're going to just grab it and we're going to bring it in, and then we're going to create a file for the word count assignment. I believe this is in your chapter assignments. It's called word count. And essentially you create a file with text in it, and you count out how many words are in it. And we can do that with the split method and the tokenizer, and we're going to do it with both. Let's go ahead and grab this try catch for grabbing the file, and then we're going to modify it. We've got our try catch. There we go. Let's just take that over to our chapter 8 Java, and let's drop it right into our main. Okay. Please put in the import classes for me so I don't have to mess around and monkey with that. Oh, I love you. Thank you very much. And Now let's get into a few things that we're going to be dealing with. Actually, let's comment this out. And what we'll do is we're going to just read in all the data in the file, all the text. So we may do a full file read-in of the text. Of course, I'm going to be looking at that. So we're going to call this words. We're going to call this words.txt. And I'm going to go ahead and create that in our project folder. I believe I put words. I'll look at the chapter 7 on where I put. I'll just go to the chapter 7 folder, grab it out where I put it in there, and rename it words.txt. So all this stuff is pretty much going to go away. We are going to say that there's some kind of problem here. We'll change that to chapter the class name to chapter 8, I guess, is an error. And you know what? Let's just blah. No, yeah, I like it. Let's just go ahead and do that. We'll do that chapter 8. The class that we're working with up above. Okay. That's just an error to tell us that the file wasn't found and where in our code in this class we couldn't find the file that we're trying to open. So then we're going to go ahead and let's just pare this down to nothing. And then of course I'm going to do a quick change around. And then I'm going to go in and I'm going to do a search in Google for Java read all text in file, something like that, so we can get it all chunked in one string. Then we're going to split, and then also we're going to tokenize the string to get the word count and print the words separately. And then we're going to have fun with some numerical value inputs and parsing. And that should be done in the try catch. Okay, so let's do this. Let's get our words.txt file in there. Let's put some words in it. I'm going to go to my chapter 7 folder. And then it'll be kind of like break time probably. It looks like, oh, okay, I put it right in the folder. Sometimes, if you're running this in DOS, in command line, you'd have to put this with your .java class. So I'm going to go ahead and grab that, and I'm going to go to my chapter 8 folder. And I'm just going to paste it here. I'm going to call this, let's see, rename words.txt. Okay, now I'm going to put in some words. And, you guys can go on the web and do whatever you want getting some words for this. I'm just going to make up some words just real quick. And let's see, let's just do a simple one. The quick brown fox jumped over the lazy, no, not lazy, the naughty border collie who always interrupts my videos. Now I'm probably spelling these incorrectly somewhere, but I don't care. And then I have to always pause the video. And let's just put some punctuation in there just because we want to read it in like maybe a paragraph. And what are the delimiters we're going to have to add for our split is we're going to have to deal with the period delimiter as well. So what we want to do is we want to delimitate based on spaces, but we probably might want to strip these periods out or something like that. So let's go ahead and save this. And let's just run this and make sure that we are actually able to open up our file. We want this output file opened. We don't really need this. We're going to go to a different method of reading the file. We're going to read it all. We're going to chunk it all in one thing. Then we're going to close it. So I'm going to go ahead and just run this and see if we get an output, the file opened. And then that'll be good enough for us to kind of come back. I'm going to do a search for, just grabbing. Okay, we're good. I will be back in a little bit. Okay, I found a good one from Geeks for Geeks. I just put in a search, Java read file into string. They have a pretty good method here. Yeah, and by the way, there's like 10 ways to do this, probably even more. So this one, I kind of like this. What we'll do is we're going to chunk this into our try-catch and just kind of see if it works. And if it does, we're going to use that as our file reader. So we probably don't need a lot of this stuff. So what I'm going to do is Control V that. Now, do they have a close method for this? Because I think this is an interesting way of doing things. It looks like it doesn't use a close. I still want to put it into try catch because it's definitely going to have a path not found throw error probably. So we'll try that out and see what happens. If not, we may have to go back to the drawing board and play around with it some more. But this, definitely do not do things this way. Please do not do things this way. This is just horrible. Yeah, use implicit file direction. All right. So it looks like path. We need probably the include for path. Let's see if the website provides this for it. Let's just, oh yeah, there it is. Let's just grab all of this actually. I'm going to just grab all of that. And I'll go back to our code, go up to the top, and we need the logger. That's for our try catch. We need probably, let's just throw it down below and get rid of duplicates. This is a duplicate. And it looks like we're using IO exception. So it looks like it throws an IO exception. So we may need to catch that. So let's do that. This is going to be, IO exception instead. So I'm going to grab that down here and we're going to instantiate an IO exception. Because look, it even lights up the class that throws it, or the object that throws it inside of it. That's so nice. Okay. All right. So we probably don't need this file not found, or the file, or the scanner. That's probably what those warnings are all about, because we're not using them now. Okay, so we're using the path object to open the file, and that's our file pointer, or path, and our file pointer is this guy right here. So then we have our string str. You know what? I built a string up here that I want to use instead. So I'm gonna call that str file. Okay, and then hopefully this actually works. We're going to find out. That would be cool. Then we can just kind of move along and have some more fun. Let's see. And just do a little cleanup so that you guys kind of know. You guys can put whatever logger you want in there. This is where I would actually do this, is I would actually replace this with ex.message or something like that. Thrown ex, well, whatever. All right, let's play. Let's see what happens. There it is. It output. You just gotta love Java. 15 different ways of doing the same thing. Very, very slow and inefficient, but very easy to work with and come up and do rapid application development that works across multiple operating systems. Okay, so here's where we've got our string that we want to deal with, and let's look at the problem that we're actually trying to solve. It's the word counter problem. Let me bring it over to the end of the chapter here and make sure that we are doing okay. Word counter. Write a program that asks the user for a name of the file. Oh golly, no, skip that. The program should display the number of words that the file contains. That is a double-digit assignment, and yes, you guys can use it and turn it in, especially if you've watched this far along. So this one is actually really simple because what we can do is we can use the string the substring, and we can build an array. The thing is the array, when we instantiate the array, we can't use the new operator because the substring, the sub function, or not the sub, but the split function. The split function instantiates the array for us and returns it back to our reference that we're going to hold. So we just need to build the string array reference. So we're just going to go ahead and we're going to call it tokens. I think I could just do it like this. Yeah, I think that'll work. And then so essentially it's just a reference. We're just declaring the pointer, and then the pointer is going to be assigned to the split of our str, our string file, our string that represents what's in our file. So I'm going to go ahead and say tokens is equal to str file. This is the way most languages do it. So we got to send it a delimiter here, a regular expression. No. I might need to do some Googling. We'll see. Okay, split. We send it the file. You know what? That actually, I may need to do some Googling. That should be the delimiter that we send in there. That's the way it should be. Let's actually throw it in the debugger and see what happens. Okay, so we open up the file. We read in the file. So we look at str file. We go down here in our autos. Here's our string. We should be able to tokenize that, and so when I step over, the tokens should be instantiated. And we look at it, length 22. I think it might have worked. So yeah, it does work like, yep, there it is. Okay. Yeah, pretty much like all other languages. You know what I would do in here is I would actually, let's see if I can add another delimiter, because it's delimiting based on the dot or the space, but we've got periods in there. So what it would do is, you see right here, video has the period in it. We could go in and tell it to trim all periods if it's in there. But let's see if video has the period in it after we run this again. So I'm going to hit stop, and it may not work this way. We may need to send in an array of delimitators. Let's see how well it does. I'm thinking that we have to send in an array of delimitators. That's the way most languages do it. Let's see. Okay, 22. Look, see, you took the V out of video. That's hilarious. It took the... Oh, that is just not good. Okay, so I'm gonna Google that split method, but in all reality, we're looking for the word counter. We could just run through every token, and after this is done running, we can remove the dot. Let's do a search for Java split delimiters. Java split delim. How to split it with delimiter. So basically, what I'm looking for is an example where we can send it a char array. So we can send it multiple delimiters. I don't know if we're going to be able to find that. So right here is an example where it does it based on a comma. We could just trim the period out of everything. Oh, there it is. There's the example. Okay, so it looks like they put brackets around the multiple delimitors. Oh, no, the bracket is a delimiter. That is interesting. Oh, it did not like the way I did the spacing of it. Okay, you know what? This is kind of interesting way of working with the split method, but it just goes to show that that's probably why we would want to use the string tokenizer class, is so we have more control over this. It looks like, let's just go ahead and copy what's in here and modify it to what I'm, actually, you know what? Those are good delimitors to have. Those are that's most punctuation that we would want to delimitate based on. You can add other punctuation in it. The space is natural, so we don't actually have to tell it the space. That's the way it should work. That's the way I would build it. Yeah, okay. So we actually don't need to say space. It's already a natural delimiter. We can just put in the punctuation. Oh, maybe there is that space there. Okay, let's look at the example again and what they did. They put all right, looks like, why are you just, that insert automatically goes in? Why are you doing that? Don't do that. This is weird. Okay, be that way. Be that way. All right. Oh, you are a nightmare. Okay. It looks like the space is in there. They do put it in there. So let's see if this works even better. And you can add other punctuation in there to delimitate based on. So let's go ahead and run the debugger again. And you know what? If it doesn't work better, I'm going to let you guys fiddle with it. I want to get to the string tokenizer class, and we'll go back to the PowerPoint and use that as an example. So let's see. Tokens, 22 tokens. That's fine, but how did it break them up? Okay, so here we go. Now it takes the dot out of the videos. So you can add, we would want to add like things like exclamation. Okay, so when you guys do this with, like, maybe you grab a paragraph from the internet and you throw it in, throw in all your other, syntax. If you wanted to, here's funny, if you wanted to delimitate on a quote, you would do a / quote. You probably would do it like that. So that you would use the escape sequence here to tell it, no, you really mean a double quote, and it's not the double quote that's actually in the code. So you do this all the time when you're working with injection. SQL injection, code injection, cross-site scripting, all kinds of crazy stuff like that. We call it an escape sequence. So if you're going to delimitate based on quotes, you would do it that way. Okay, so to print out the answer, then what I would do is I would output system.out.print, and I would say there are blah plus tokens dot count or dot length, which is an integer, so it'll automatically convert words in your file. Okay, let's see if that works correctly. And we know the output should be 22. We've already done it in the debugger. It looks like the split method is working appropriately. So let's go ahead and run this. There are 22 words in your file. Wonderful. Sweet. Good stuff. Okay, let's do it with the other example. And you know what's coming. It's break time. Yep. Gotta go. The border collies are driving me nuts already. Got to go to the park eventually here before they start punching me in the face. So I'll be back. Okay, and we're back. So what I did is we're going to actually do an example here called, the string tokenizer. So I did a search for Java string tokenizer, and I'm going to take this one, Geeks for Geeks. And so I'm just going to grab, it looks like we need the utilities import. We probably already have it in that example. So, okay, fine. No. All right, crazy border collie already. I'll be right back. I'm going to leave things running though. Come on. Okay, outside. Come on, man. There you go. No, you stay. Okay, so let's grab this code and play with it. We're going to just grab this bit right here. Let's see. I think that's enough. We'll just grab that and throw it in. And then we're going to come in here to our example. And let me kind of get in here. Let's just get rid of all this stuff. And we'll throw this in here. And if anything is thrown from this code in here, and I may need to, it's always dangerous when you're copying and pasting things from the internet. You get weird characters in there. Sometimes you can't even see them because the editor doesn't know how to show them. Let's see what kind of error we're getting here. Oh, okay. We need the tokenizer class. So we needed to add this guy up there. Thank you, NetBeans. I appreciate that. This is going to, oh no, we want to do this with the file, don't we? Oh my goodness. I just messed everything up. Control Z is your best friend, by the way. Okay, good. We want to open the file and then tokenize the file. Oh, geez, I'm getting a little crazy. All right. Let's go up here now. We got that code. We got our file opened. And we're going to instantiate a new tokenizer. But we're not going to put in this literal string. We're going to put in our tokenizer, and then we're going to put in our delimiters. So let's do Control Z again because we already had the delimiters in our code that we used, our split code. So we're going to come back and use that again. All right. Now we might be moving along. Okay, we got our string tokenizer class. We're going to take that out. We're going to do it with spaces first. Then we may, but this is going to be our str file. And let's just comment this out because we're not going to be doing it with the split method anymore. There we go. Tokenizer, yes, we got to add that again. Let's go over here, click on it, and have it add the thing for us. Oh, it does not like me anymore. Why are you doing this? Oh, because I got this error up here and it doesn't know what this is. Okay. And then, okay, now we should be able to have it auto for us. Okay, now we're going to have to include string tokenizer. So let's do this. I think it's, what was it? It was include string token. Let's see, import tokenizer. Let's just do a search in Google for import Java string tokenizer, and let's just grab the code for that. Maybe Geeks for Geeks? No, we're looking at that. Java point. There we go. Import. Oh, it's a utility from there. Okay, that's fine. All right. So let's get that in there for our import. Get rid of your white space that you paste in. That could be weird characters. So we got our tokenizer class in. Now we are still having an issue. Oh, str file was the error. Okay, there we go. Now str file is going to be a string that we create up here. So let's add that again. String str file. Then we read the string from the file. Then we send the string to the tokenizer. We're going to have an initial delimiter of these guys, and then we're going to add these guys here in a little bit and see if it kind of works the same way. I'm kind of thinking it does. So we'll see. And then here, we're just going to print out while we have more tokens. And you see we don't have our parents, our squigglies there, our little hoo-haws. We probably should add those, but you know, if you're only doing one line, you don't really need to. That's fine. And then we don't need this. It looks like it's another example of tokens, so we can just get rid of this. Here we go. Okay, let's make this more pretty. Okay, and then, oh, we should probably tab this in just with the try catch. Okay, let's see if it prints the words. I'm not even going to throw it in the debugger. Looks like I probably have some errors here. Oh, capital S for string, please. Let's run it. Okay, there we go. It's got all our words. Now you see that it's working with the period in there. So we got to add. Let's try this method right here. Putting this over here and seeing if it behaves the same way. And run it again. And it does. It behaves the same way, like it should. Okay, so now all we have to do is, you know, the reason for the tokenizer and to be able to use this tokenizer is, what if we want to do a behavior while we are tokenizing, like compile things, you know, stuff like that. We don't always want to have to tokenize everything, throw it in the array, and then process the array. Sometimes we just want to process the tokens as they come, especially if you don't have a set size of tokens. Maybe you are reading these tokens and you don't know how many you're going to get from some kind of file, from some kind of stream. So all we got to do here is there's probably an st1.length. So we can add a counter there, but actually, you know what? There would be, no, because it's only grabbing as it goes. So we would need a counter. Yeah. So let's go ahead and just put a counter in here. Set it to 0. And then every time we get a token, let's do a counter plus plus. And then we can do our output of system.out.print. You have counter plus words. Period. Okay. All right, let's run it. We don't need to print it out each token. Looks like it's not liking something. Again, we might have to do, there's probably something wrong here. Yeah. Did I print string? Oh, maybe I'm stuck running and it died. All right, let's do this. Oh, duh. I'm a silly goose. I just created a runaway loop. Because if you've got tokens, you've got to process those tokens by saying go to the next token. And you know what you can do is you can just create a quick string here that you don't do anything with. String called token. And say token is equal to every time you get another token. So yeah, I was never going through all the tokens. So essentially, it's always got more tokens because I haven't gone to the next token in the string of words. All right, now we should have something that'll work. Let's do a build clean. Looks like my play button is not liking me. Okay, there it is. You have 22 words. Okay, so that's working with the tokenizer, and this token I think we're not really even using. I don't know why it's giving us a warning. Variable token is never used. Oh, it's because it's in a while, and the while is not guaranteed to run, so that's fine. You can assign it to an empty value and get rid of that warning. Something like that. Oh no, it still doesn't like us. That's fine. Oh well. You could use it out here, and then it would remove that token because we're using it here in the while loop, and since the while loop isn't guaranteed to run, it's putting out that error that it's never used. Yeah, Java, or NetBeans. Okay, sometimes, yeah, whatever. Okay, so here's the next thing that I wanted to get into now that we've got this done, and that is essentially converting numerical values to numerical values that are entered as text to an actual integer. And that's covered in your PowerPoints here. Let's see, right here with the parse function. Now you want to make sure that you do this in a try-catch block. That's the thing, is because if you try to parse an integer but you put an alpha character in there, it's gonna throw an error. So let's go ahead and let's get rid of all this stuff. Because we're just gonna play with this, and now that that's all done, I'm just gonna get rid of it. And let's say here that we're gonna do this. Oh wait, no, Control Z. Let's go grab that code from the PowerPoint, which is really a dangerous place to grab code. Let's just grab that. Maybe you need to right click on it and say actual copy. Now I'm going to go in here and I'm going to paste it. See, he does not like me copying that code for some reason. I do not know why. Why won't you let me copy this? So typical. Let's just do this. Let's just write it in. Int v equals to integer dot parse int, and then we're going to put the value 2346. But here's what we're going to do. We're going to screw it up. We're going to simulate a bad input by the user when you ask them for a number, and they actually accidentally put in an alpha character. So this is where you want to catch your exception or have some kind of try-catch block. And it looks like we probably, the exception that we're catching is probably not liking us. So we want to go with a try-catch block for a parse. So let's do a search for Java try-catch parse. Java try-catch parse. So the parse exception. Oh, it looks like we just need to create a parse exception so that we can catch it, which means we probably need to include it. So let's do this. Back to our code. Instead of an IO exception, we're going to call this a parse exception. Do they do it with a lowercase e? Wonderful. Let's go back to the examples. Let's get a better website. Treehouse. Let's see if they got something good. Oh, so we do a catch parse error. Okay, let's try that out. Let's see. Let's go back to that code again. Catch parse error. You know what? I'm going to go play with this, get it set up correctly, and then we'll talk about it. Be right back, guys. Okay, we're back. It's the number format exception. So we're going to go ahead and when you do a parse int, you do your try catch around it so that you can catch the number format exception when somebody tries to put the alpha inside of an input. And then, you know, what this will do is it'll output to your console this particular error down here where it says, you know, hey, what class did this happen in? Is this a big problem? Yes or no? No, whatever. But essentially, it tells you, hey, this is where the exception happened and what value the exception happened on. So to fix this and make sure that the error isn't thrown is, of course, to send the parse int function an actual number in its ASCII equivalent. So now when we run this, we don't get any problems. There's no errors. But if we put an alpha in there, we get an error. But the whole idea of this is so that we can take this ASCII value from the user and do things like v is equal to v plus 25, and then you know, let's say that this guy is 200 and whatnot. So when you're reading numbers from the files, you want to have your try catch, especially when you use any kind of parse function to validate your input. And that's, you know, a responsibility that you always have, and it's also a security issue as well. So now that we've processed the integer v, we can do our output of it, and we can print it in its processed form, where we should get the value 225. And there's our 225. Okay, guys, this is it. Thank you. Have a good one.